Welcome back. Now, in this lecture, we shall discuss the group 4 elements, right? They are called group 4 elements because they have 4 outermost electrons. So it means that members belonging to this group have partially filled valence electrons, 4 of 8. So that's why we said hydrogen can be put to this group. Hydrogen is put in group 1 because it has 1 valence electron. It can be put in group 4 because it has partially filled valence electrons. And it can be put to group 7 because it needs 1 more electron to attain stability. Now, group 4 elements, if you don't call them group 4, if you do not call them group 4 elements, they can also be called the carbon family. And why are they called carbon family? They're called carbon family because carbon is the first member of the group. So carbon happens to be the first member of the group, and as a result, we call that group carbon family. What members do we have in group 4 of the periodic table? We have carbon, C, right? We have silicon, it's a group 4 element. We have germanium. Germanium is Ge. We have tin, which is a group 4 element, Sn, and lead, Pb. So these are group 4 elements: carbon, silicon, germanium, tin, and lead, right? So all of them have 4 valence electrons, and that's why they are put to that group. Now, what are the unique features of group 4 elements? What are their chemical properties? Now let's discuss the chemical properties of group 4. Number 1, they are tetravalent. So they are tetravalent. What does this mean? It means that they have 4 outermost electrons. Alright, so group 4 elements have 4 outermost electrons, all of them. Number 2, okay, they do not ionize. Instead, they prefer sharing of electrons. That is covalent bonding, right? In chemical reactions. This is because group 4 elements have 4 valence electrons, right? And because they have 4 valence electrons, they can't lose their 4. At the same time, no element is willing to give them 4. So what do? They go to another element with 4 or with 2. If it's an element with 2 valence electrons, they need 2 of it. If it's an element with 1 valence electron, they need 4 of it. In short, all they need is 4 valence electrons. And then they share their electrons, which is called covalent bonding. So they prefer sharing of electrons in chemical reactions. That is, the kind of bond they love to form is covalent bond. Okay, what other characteristics do they have? Upper members of this group are non-metallic. That is, carbon is a non-metal. Carbon is a non-metal. Silicon and germanium are metalloids. Silicon and germanium are metalloids, while tin and lead are metals. So you see what we said in the previous lecture, that members found at the bottom of the periodic table tend to be more metallic than those at the superior parts of the same group. Alright? So that's another factor. Now, which other property do they have? What can we say about their oxidation states? They have 2 oxidation states. Actually, 3 oxidation states. They have 3 oxidation states. They have 3 oxidation states, which is an oxidation state of +2 in the case of carbon 2 oxide, right? In the case of carbon 2 oxide, they have an oxidation state of +2. An oxidation state of +4 in the case of carbon 4 oxide, silicon dioxide, tin 2 oxide, right, and lead 2 oxide. So you can see this. So this is a +4 oxidation state. CO, PbO, SNO, all these are +2 oxidation states, as you can see. And then they have the third oxidation state, which is very rare to come by, is an oxidation state. It's an oxidation state of -4, right? You know, we said they can either gain 4 or lose 4, right? But they prefer to share. If they gain 4, they will be -4. They gain 4 electrons, they'll be -4. They lose 4 electrons in chemical reactions, they'll be +4, right? So in this case now, they want to gain 4 electrons. All right, and what examples do we have? Carbon to have a +4 oxidation state. In hydrocarbons, the carbon in hydrocarbons have -4 oxidation states. So an example is methane. Methane here has an oxidation state of -4. It is important, please, it's very important you know that. Now, what other factors do we have? The oxide, because the superior member has, I think this is 0.5, because the superior member has non-metals, the middle metalloids, and the bottom pure metals, right? They have different oxides. And what do we mean? The oxide of carbon is neutral in carbon 2 oxide. So carbon 2 oxide is a neutral oxide. It has no effect on litmus, right? But acidic in carbon 4 oxide. Carbon 4 oxide is an acidic gas. And how do you know carbon 4 oxide is an acidic gas? You know, when we talked about acid, bases, and salts, we talked about acid anhydrides. They are acids lacking water. So when you add water to them, they give you actual acids. Now, if you add water to carbon 4 oxide, right, what becomes of it? It becomes H2CO3, which is an acid. So it means carbon 4 oxide is an acid anhydride, meaning acid lacking water. You know, when you use the word an means lacking. Okay, it's a prefix. It means lack or absence. Hydride means water. So acid anhydride means it is an acid but it lacks water. So carbon 4 oxide is acidic. But what about the lower members? The oxides of tin and lead are amphoteric. They are amphoteric in tin 2 oxide and lead 2 oxide. Means that these two compounds can act as an acid, they can also act as a base, but basic in tin 2 oxide and lead 2 oxide. And why is this? This is because oxygen, the presence of oxygen the abundance of oxygen tells us or signifies a base. When we define a base, we say a base is anything that gives off an oxide ion. That oxide ion comes from oxygen or hydroxide ion as the only negative ions when dissolved in water. So it means bases give off oxide ions, which tells you that oxygen defines bases, or oxide ions defines bases. Okay, so that's it. Now, what other properties do we have? Because they have non-metals, which is silicon and germanium, they are, oh sorry, should do that in blue. They are tetravalent semiconductors. They are tetravalent semiconductors. Okay, let's round off with this last point. Oh, sorry, not the last point. What can we say about the electronic configuration? What block do they belong? What block do they belong? They are p block elements. Why? Because they are p block element because carbon with an atomic number of 6 has a configuration 1s2, 2s2, and 2p6. Carbon with an atomic number of 6 has a configuration of 1s2, 2s2, and 2p2, right? Which other one? So you have them that way. You can see carbon here is a p block element, and the rest of other group 4 elements. And finally, they have unique properties. They have unique properties. That means all members of group 4 show unique properties, such as 1. Catenation, 2. Excitation, and 3. Hybridization. But it is important to note that these unique properties are more pronounced in carbon. As you come from carbon, as you come from carbon to silicon, to germanium, to tin, to lead, these properties are most pronounced in the upper members and least pronounced in the lower members. So lead shows the least tendency to catenate. It shows the least tendency for excitation. It shows the least tendency for hybridization. While carbon shows the greatest affinity for catenation, excitation, and hybridization. These have been defined in our lecture on unique properties of carbon, on Introduction to Organic Chemistry. We defined catenation, excitation, and hybridization. So to understand what these three terminologies are, please go to our lecture on organic chemistry, Introduction to Organic Chemistry, and unique properties of carbon. You'll find them there. So guys, that sums up all we have for group 4 elements. I hope it made sense. I hope it was insightful enough and educative enough. Thank you for sticking with us, and in the next lecture, we'll move to group 5 family.